Hey, it's Tony from Adafruit, and in this video we're going to look at what is MicroPython. And this is actually a reprise or a redo of a video I've done in the past, but the twitch.tv/programming channel just launched this week, and so I figured this would be a good thing to do and put under the programming channel because it's a cool thing that you might not know you could program with Python on a little microcontroller. And that's what I wanted to show, is what MicroPython is, what you can do with it, and maybe how it compares to things like Arduino or Raspberry Pi that you might have heard of, and you might have used, you might be familiar with. So you can kind of see what you could do with MicroPython and why it might be a really interesting thing to check out for working with hardware, or even just in general for working with Python. It's a really cool little Python interpreter. So let's just kind of dive in. We'll go to kind of the main setup that I do for a lot of these things, and we'll look at a whole lot of things. So in the upper right hand corner, we'll come back to this. There's a bunch of hardware here, but I'm going to show off a few different MicroPython boards. Right here, this is actually a guide that I wrote in the Adafruit learning system, so learn.adafruit.com. And by the way, for any web page I show, I'll put a link in the description when this goes up on YouTube, and you can look at that and see a little bit easier link to these. But this is a guide that I wrote that explains what is MicroPython. So I'm just going to go through some of the details in this guide, really try to hit the highlights, keep it short and sweet. I want to make this maybe 20 minutes or so at most. So, just to give you an idea what this is. So definitely check out this guide at the end though, if you're interested in learning more. I have a lot of things like links at the bottom, links to like documentation on all the boards, a whole bunch of guides. I think I've done about 10 guides now on MicroPython. So I cover a bunch of the basics, and then I've also gotten into some of the hardware access with it. So really cool stuff. But let's just kind of dive in at the top, like, okay, what is MicroPython? So MicroPython, and by the way, the website for it is micropython.org. Definitely check it out. It's kind of the main place, kind of the jumping off point for learning more about MicroPython. But it is what it says. It's a tiny Python interpreter that can run on microcontrollers. So it's not a port of the Python that you might run on your desktop. That's called CPython in most cases. Because that's a really resource-intensive version of Python. It's made to run on servers and desktops that have gigabytes of memory and lots of disk space. So it's nice that CPython or normal Python gives you a lot of functionality out of the box, but it's hard to take that and make it run on a little chip like this guy right here. This is called the Pi board, and this is a little STM32 Cortex M4 microprocessor, which is actually a pretty powerful microprocessor, but nowhere near as powerful as something like, maybe this guy. This is a Raspberry Pi, so this has an ARM Cortex processor, but a different one. This one's actually much more capable, at least as far as running like a full operating system like Linux or something like that. So that's what MicroPython was intended to do, is to take Python, and it's actually a full re-implementation of Python, but to run in the low memory and low power environments of these little microcontrollers. And it actually works amazingly well. There have been some Python on microcontroller projects in the past, but MicroPython was really targeted from the start to be as close to normal Python and Python 3.0 specifically as possible. So you'll find that the core Python language is available on the microcontroller, which is really neat. So I figured let's just kind of dive in and let me just show you that. It's actually, actions speak a little bit louder than words here. So I'm going to plug this in. This is the Pi board, like I mentioned, and I'm going to plug it in. It has a little serial or a little USB connection right here. So it just plugs in like an Arduino basically to your computer. And we'll see, it's not going to do much right now, but I'll show you on my desktop something interesting. So, and you can see the light comes on here. And by the way, on this board, it has a whole bunch of these little holes on the outside. You can solder in headers and then connect wires to these. It has a little micro SD card reader right there, so you can plug in and read that. I believe it has an accelerometer on there also, a few other peripherals and things. Really nice board. And it's, by the way, kind of the original MicroPython board. So the very first one has really good support for the language. It helps out the MicroPython organization, so definitely check that board out. And again, I'll have links in the description when this is up on YouTube, or go to this What is MicroPython guide on learn.adafruit.com, and this has links to all the boards there too. Okay, so I plugged this thing in, and it actually shows up as a serial device. So I'm on a Mac, I can use the screen program to connect to a serial device. If you're on Windows, you can use PuTTY. That's just a real simple terminal program, and it's just like talking to any serial device. And by the way, for the Pi board, you do on Windows have to install a driver to make it visible. I have more info in the guides, the MicroPython guides that I mentioned. So okay, so I'm just going to use the screen command, and I have to point it at the serial device. So it's this USB modem device, 115200 baud. And okay, like this, if you're a Python user, this might look kind of familiar. This looks like a Python prompt, and in fact it is. So, you know, if you want to do the basic hello world, there it is, hello world. And this is actually running on this little chip right here. So there's nothing on my computer. Even though this looks like a terminal on my computer, this is Python running on this microcontroller. And this is real Python. Like, you know, if you want to do fancier string formatting, so like print hello world, you know, with something inside of here, and maybe I put like a floating point number in here, I don't know, 100.25 or something, you know, you can do that. And so it prints it out. Or maybe you want to get fancier, and let's say I only want to show like 1 decimal point after this. I believe that's the syntax. So, you know, there you go. It's, like I said, the full Python 3 core language. You can get even fancier. So like if you are an advanced Python user, you know, you know a lot of things about Python, all of the fun stuff you can do in Python, like kind of a functional style of programming. So like if you wanted to maybe like filter all the even numbers, let's say lambda x, where x modulo 2, oops, x modulo 2. So let's find all the even numbers, equals 0. And then I want to grab the range of numbers, or how about I want to make a list of the range of numbers from, I don't know, 1 to 10. How about we'll try that. So, oops, I need to actually tell it to enumerate this list here. I'm still having some fun with Python 3 stuff. All right, so we'll turn this into a list then. So basically the filter function is going to apply this little lambda function right here to everything in this list, which is just going to be a list of the numbers 1 through 10. So we should see it return the even numbers, and hey, look at that. So that's pretty cool. Like, and again, this is all running on this microcontroller. This is the kind of thing where if you're used to programming a microcontroller in low-level languages like C or like Arduino that's based on C and C++, you can't really do stuff like this. You know, you can't create a lambda function. There's not really this functional style of programming, but with MicroPython, because it implements the Python language, you can do that. This totally works. Like, this is really cool. And you don't have to get this advanced. I mean, if you want, you can just define a Python function. You know, like how about isEven? We'll make a function where you pass in a number, x, and then it returns, you know, if x modulo 2 is 0, then return true, else return false. So, you know, this will basically tell us, is this number even or not? And you can see as I type this, like it knows that this is a function. It's actually indenting for me. If I press enter 3 times, it'll actually close out the function that I just defined. And so now I can say, okay, is even 10 true? Is even 11 false? You know, this works. So this is really cool and really powerful. You know, I'm able to type in Python code and have it be interpreted and run just as if I was running this on my desktop. The other really cool thing to mention here too is that, you know, this is an interactive Python prompt that I'm working with right here. So if I want to interact with my hardware, I don't have to write a program and compile it, which means I probably have to install some tools. You know, if I'm lucky, maybe something like Arduino has already done that messy toolchain work for me and it's totally hidden. I just click a button that says upload and it works. But if I'm not lucky, then I need to know how to set up like a whole ARM GCC toolchain and figure out, you know, how to load code onto my board and things like that. Really messy and really annoying sometimes. Whereas with MicroPython, you've got this REPL or read, evaluate, print loop, which is what you're looking at right here. And so this is just an interactive Python terminal. This is great if you're just learning and you're a beginner and you just want to play around with like, okay, I want to turn an LED on. So you can connect to the REPL, you can run the commands to turn on an LED, for example. And you don't have to like learn all of like what is a program, how do I compile this thing. So again, really good for beginners. But like I mentioned before, this is full Python. This is not a cut down Python. And so you can actually do real things with this. You can create classes, you can create functions, you can do functional programming, you can do all the fun stuff that you like with Python on a microcontroller here. So, really cool, really powerful stuff. Okay, so that was one demo of the Pi board here. Like I mentioned, really nice board, worth checking out, very powerful board. So we'll close this out. I'll show another demo now. So this is a different board right here. This is actually a couple things. Let me move it around a little more so you can see it here. So this right here is the Feather Huzzah ESP8266, which is a version of this little Wi-Fi microcontroller called the ESP8266. Really nice little microcontroller, low cost, has Wi-Fi, and the cool thing is people have ported MicroPython to it so that you can actually run MicroPython just like you saw on the Pi board. Now this one's a little fancy. I've got a few things connected to it. This is a little ring of neopixels, and then this is a DHT22 humidity sensor, temperature humidity sensor. So both of these are connected to this board, and let's see, I can actually interact with these devices using MicroPython. So I'm going to plug this in. And so I'm just going to show you like how simple some of the hardware interaction can be with this. So again, I'm going to connect to the screen terminal here, the serial terminal basically, and I'm going to connect to this board. And again, you see I get like this little Python prompt. And for this, I'm actually going to import some modules and run some code that reads this hardware. So let's control the neopixels first. So there's a neopixel module you can import, and then there's also this machine module that's basically the interface to all of the hardware APIs in MicroPython. And so I can actually create a neopixel object. So neopixel.neopixel. I have to tell it which pin is connected to the neopixels because they take in, there's one wire that's the signal wire, and so that kind of sends a fast little pulse of signals that tells all the pixels what color they should light up. So you say, okay, here's the pin, and for this board I have it wired up to pin 15, and I need to tell it that that's an output pin, and then I need to tell it the number of neopixels. So for this ring, there's 16 neopixels. And now I can actually, if I want, I can just set all the pixels to a color. So there's a fill command, and this just takes in a tuple, like 3 values basically, the red, green, blue components. So if I want to light these all up, how about pink? So red 255 and blue 255, just like HTML colors. You can send like hex values in here if you want. These are just decimal values, but 0 to 255. So okay, so we'll fill this up. Now nothing changed yet because the way the neopixels work, you have to call a write function, which will actually send out that color data to the pixels. So I do that, and oh, actually I got yellow in that case. So I did red and green instead of red and blue. So hey, that's fine. We can fix this though. So again, this is interactive REPL. If I want, I can change the colors here. So now it's red, no green, and then full blue. So red and blue, that should be pink. And now when I write this out, then you can see, hey, yeah, it looks like a pink color there. So really cool. And if I want, I can like cut the intensity down. Let's say about half red. So it's like a bluish pink kind of color, and then write these out. And you can kind of tell it changed a little bit. It's the camera, the exposure. This thing's so bright, it's a little hard to see. But look at how simple that is. I've just interactively controlled some neopixels with a Python terminal running Python code. Really cool and powerful. Again, if you've used Arduino or something similar, you would have to like write a program, you'd have to upload it, you'd have to install the tools and stuff first, and then install the libraries also for that. So very, very powerful what MicroPython has here with this interactive terminal that you can use. Now there's also this humidity sensor, but you know what, just to keep this short, I'm going to show something different here. I'm going to show, I actually wrote some code ahead of time right here. So this is Python code. So this is using this DHT sensor module. You can see I'm actually creating this neopixel object just like I showed kind of interactively at the terminal. Then I create this DHT sensor object, and then I just jump right into a loop here. And what I'm doing is I'm taking a measurement with the DHT sensor, I grab the humidity, and then I just use that humidity value to turn the pixels either blue or red, depending on the percent of humidity. So if there's 100% humidity, then it's going to be completely red. If it's 0% humidity, it'll be completely blue. And if it's like 50%, it'll be a pinkish color kind of in between. And so that's what this code is doing right here. I'm just taking that humidity, which is a value from 0 to 100, and then just scaling my red component between 0 and 255 based on where it lies within that 0 to 100. Same exact thing for blue, but I'm just flipping it, doing the inverse. So I take 100 minus my humidity. So, if I had 75% humidity, this will actually be a value of 25. So it's just, inverting it in some ways. And then scaling it down to a value between 0 and 1. and then multiplying by 255 to give me that kind of final blue color components. And then I'm just using that fill value. But if you wanted, you could actually write individual pixels. Like pixel 0, I could set to some color value inside of here if I wanted. So you have full control over all the pixels. You don't have to fill them, but just for simplicity, I'm going to fill them all. Then I write them out and just delay for a second, sleep. And I have this little try catch here because sometimes when you measure the sensor, you might get a timeout because it's a very fast signal it's trying to read here. So this just kind of ignores it. But this is cool. Like you can see, this is real Python. This is exception handling, really powerful stuff you can do here with this. So let's run this script. And I'm going to use a tool that I created called Ampy that just takes Python code and sends it over to a MicroPython board over the serial connection and tells it to run that code. So there's a little Ampy command. And by the way, I have a whole guide on Ampy. If you go to that What is MicroPython guide, I link to how to load files and run code, and that talks about this tool called Ampy. There are other tools too, by the way, that can do this. But let's do Ampy run -n tells it, because I have an infinite loop, I'm just telling Ampy, hey, don't wait for this program to finish, just start running it. And then it's this dhtpixel.py, and this is going to send it to the board. Okay, so now it's running. And you notice it's pink, which kind of means it's around 50% humidity. And actually, if I open up the terminal here, I should see every time, I didn't put in a print here. Hey, you know what? Let's change the code. Let's have it print out the humidity value that it got. So we'll say print humidity, and this is going to be floating point value. So we'll say, we'll give it 2 decimal places after this. And then format, so we'll have it print out the humidity. Okay, so now let's cancel, let's exit our terminal, and let's run this again now. And now let's look at our terminal here, and we should see, there we go. So we've got about 60% humidity. Now I'm going to breathe on this sensor. That's going to increase the humidity, and let's see what happens. And it takes about 2 seconds for the sensor. But notice, hey, the humidity is going up, and it's getting redder. It's a little hard to tell on the camera, but it's definitely red. So we're at like 93%, and it's pretty much completely red, at this point. And then the humidity is slowly going to go back down, and you'll see it gets back down to like a pinkish level, like maybe back down to 60% humidity or so. So this is pretty cool, I think, in that, I've got a Python script right here. I just ran a little command that sent it over to this microprocessor. It's running directly on this board, and it's interacting with hardware. I'm lighting up pixels. I'm reading this temperature humidity sensor. Really cool stuff, the kind of thing that you might have done in Arduino, but maybe had a little bit of trouble with because it's a different language, a little bit more of a process there, more tools and things you need to get familiar with. So I think with MicroPython, especially for beginners, there's a lot of potential here. But again, I don't want to say that this is only for beginners because MicroPython was made to be real Python. So you're not losing a lot of capabilities. Almost anything you can do in Python, you can do in MicroPython. Now, the big caveat of that is that there is a limit to what these boards can do. Like the ESP8266 right here, it only has 96 kilobytes of memory, of RAM. And the flash memory or the kind of storage space available varies by each board, but this one has 4 megabytes. So, most people watching this probably don't even remember what it was like when computers only had 4 megabytes of hard disk space and just kilobytes of memory. So it's been a long time since then. And the fact that Python can run on this is impressive. But, because this is so low spec, you're not going to have the entire Python standard library. You're not going to have a SQLite database on here necessarily. Although one day, who knows, someone might be able to port that. All of the bells and whistles that Python gives you, or it's sometimes called batteries included, where Python will give you a bunch of cool things in the standard library. It's, just a fact of life. You can't squeeze that all onto boards like this. But a lot of it is there, and so there's a lot of potential here. And the cool thing, though, is that, even though you can't have all of that functionality built in, if you need to add extra functionality, if you're interacting with hardware, if you are an embedded engineer and, you like to get your hands dirty with C programming and assembly language and really talk to those peripherals at a low level, MicroPython can actually let you combine C code with Python code. So you can write C functions that your MicroPython code will call. And in fact, things like lighting these neopixels and reading this little DHT sensor, at a low level, there's a C function that someone implemented and is in the MicroPython firmware. So you can add your own C code that talks to your hardware and does exactly what you need to do. And that's a really powerful thing because it lets you write a program where your high-level code or your business logic is in easy easy to understand Python code, something that anyone can look at. You know, it's easy to reason about, it's maybe cleaner and simpler. And then when you need to have like high performance or really well-known memory usage, or just talking to peripherals or hardware at a low level, you can do that. You can drop down to C or assembly in some of these lower levels and add that functionality where you need, and then integrate that with Python really easily. So that's really cool and really powerful, and something that I wanted to get across in this video is that MicroPython is really good for just the beginners that are getting started and want to play with hardware. You know, like you saw, you've got this cool little terminal here. You can start running Python code. You can see the results of it. You don't have to have all of these tools and compilers and things set up. But if you're an advanced user and you love having tools and compilers and all that stuff, you can start using MicroPython and finding easy ways to simplify your workflow and maybe simplify the things that you're building. So you've got really easy to understand logic. You know, there's really cool things like this Wi-Fi microcontroller. It has full network access. It can talk using sockets to like web servers. It can download, it can call a web API, it can parse JSON data. Cool stuff for Internet of Things. Lots of neat applications there. And I think MicroPython is going to be a perfect fit for that, because your logic can be in Python, and then talking to hardware and stuff, you implement that in C or drop down to lower levels if you need to. And you know, if you're not that advanced, I think pretty soon we're going to see an interesting middle ground where, just like with Arduino, you get this critical mass of lots of interesting libraries and modules, so that maybe you don't know how to talk C to all these peripherals, but at some point someone's going to have a library like this DHT and NeoPixel library that I'm using that's built in. You can pull down that library, add it to your own scripts, start using it, and talk to cool hardware, so that, you know, just using Python code, you're able to do this. So that's what I wanted to get across, is just what are some interesting things. You know, what is MicroPython? What can it do? You know, why might you want to use this? There's one more little demo I wanted to do, so I'm going to close out of this. I'll show off one more interesting board. So let me disconnect this. Okay, so this board right here, this is the MicroBit, and you can't get this in America, unfortunately, yet, although pretty soon I think they'll eventually have this available. This was given to every, I think, 7th grader in the UK, so over like around 1 million of these boards were given out. And it's a neat little microcontroller. So it's a little Bluetooth kind of enabled microcontroller. On the back, it has some peripherals. So this is a grid of LEDs and some buttons and things. And there's some GPIO that you can connect to on this little card edge connector here. So cool little device, which also can run MicroPython. And there's actually some really nice tooling that they've done for this. So I'll show you the way that I program this thing. So first of all, I plug it in. And let's see, it might have been running a script already. Yeah, so it was actually running something already. So it's actually running some Python code that I had actually done in a previous demo. But you plug this thing in, and you go to this website. I'm going to say, okay, I'm going to create some code for this. And then you click the language you want to use. You can program this in different languages. They have like a block-based language, but they've also got Python here. So let's make a new Python project for this. And this is cool. This is all in a web editor right here. And it's going to dump me into this editor, and it's got just a simple little MicroPython script ready to go out of the box. And they've actually given you some high-level libraries here, like this display.scroll that can scroll a message. So we'll just say, you know, let's say instead of hello world, we'll say MicroPython is cool, and we'll scroll that across. And so, okay, now let's say we'll click this download. And then the way that this works, you download this hex file and you drag it to the MicroBit. So this is going to show up on your computer as a drive. And so I'm going to do that kind of on the side here. I'll drag it over and I'll show you, and it should start running our code in a second. Okay, so I'm going to drag it over to the MicroBit. So I just dragged it over, and you can actually see it's flashing. It's programming it right now. And you can see here it's copying that script over. And in a second, it'll finish. And okay, this is cool. Let's see what it's doing. MicroPython, hopefully, is cool, almost. There we go. So you can see it's running our code. So this is cool, and I think this will hopefully be the future of all of the MicroPython boards. For now, this is only with the MicroBit, but I think, you know, again, MicroPython is still a little bit new. It's only around 3 years old, so it's a lot of cool things are starting to be created for it. And like I said, there's some tools out there already. I think we'll see a lot more tools like this, but I just wanted to show, like, this is the potential. This is what we could see in the future. You know, really easy to use, because this is all just simple serial connections. You know, you don't have to have all of this compiler and different tool chain and all this complexity, it can really be as simple as going to a web page, writing some code, clicking some buttons, and you've got cool stuff happening on hardware right here. And again, this is real Python code, so you can do almost anything that normal Python can do in MicroPython here. So that's what I wanted to show. Just a few demos here of, again, the Pi board was the first one that I showed off. Just real simple, but very capable board. Then the ESP8266 talking to a few different peripherals. And I'll mention also there are other boards. So the YPi, this is another board that I didn't show a demo for, but this is another Wi-Fi based MicroPython board. It also has a very nice editor, kind of like the MicroBit right here. So a good option if you want to check out something that's just out of the box running MicroPython to get more get started with it a little more easily. So okay, so that's what MicroPython was and what it can do. I wanted to talk a little bit about maybe how it compares. So you might be familiar with something like this. So this is an Arduino. This is Leonardo, but there's all kinds of different types. There's the Uno, there's lots of different Arduino boards. But the important thing is that the Arduino, this Leonardo, is similar to these boards in that it has just a little microprocessor. It doesn't run a full operating system. You don't have the ability to like SSH into this thing and run Python code. It has this tiny little 8-bit microcontroller on here, just like these other boards. Now these other boards have more powerful microcontrollers because unfortunately the microcontroller on the Leonardo and most of the Arduinos isn't powerful enough to run MicroPython. It's just a little too little memory and a little too slow for it. But the same kind of thing that you can do with an Arduino, you can do with these MicroPython boards. So talking to like GPIO pins, on the Arduino here, connecting peripherals and talking to them, you can do that in MicroPython. So again, just think of MicroPython as almost like Arduino, but using the Python programming language and having a little bit more capabilities than it. Now, the one thing though is that MicroPython, the language, it is really nice and it's fast and it's it runs in these low memory environments, but it might not be as fast as the code that you put on an Arduino because there is this step where the code has to be interpreted, which means that it has to look at what's the Python code and then convert that into the code that actually runs on the CPUs and little boards right here. And so there's a little bit of overhead to that, but it's not as bad as you think. Sometimes people jump to thinking, oh man, this is going to be slow and bad, but it's really not so bad. So it's definitely not something worth casting it aside. Give it a shot and I think you'll find that it works well. So that's how it compares maybe to Arduino. And then another comparison is this guy. This is a Raspberry Pi. So this is a full Linux machine. You can connect this. It's got network connectivity. You can connect to it with tools like SSH. It runs the C Python, like real Python, I guess I would say. And so you can do lots of things with that. But it's, you pay for that, so it's a little bit higher cost, higher power consumption. This thing pulls at least like 100 milliamps or so sometimes, where some of these boards, if you put them in a low power sleep, they're pulling like, like microamps of current sometimes, or just, much less current than this board, than the Raspberry Pi. So, you're gonna use a little more power. You might have more capabilities though. There's more memory. You can run, maybe more advanced programs on here. So again, MicroPython, you might even think of it kind of like combining Arduino and Raspberry Pi, put the best of both of those into one board. So it's a little board, potentially low power consumption, small size, but can talk to hardware, can interact with it directly, and all programmed with Python, like a high-level programming language. So that's a really cool and powerful thing, I think, that's definitely worth checking out. If you're familiar with Python and you're looking to play with hardware, MicroPython is awesome. If you're new to hardware, MicroPython is awesome too, because you've got like nice tools, like this MicroBit has a beautiful web editor, or the little the REPL where you can start running code. That's also really cool. So it's great for kind of both those audiences, I think, here. So I'm going to wrap it up. I wanted to keep this to about 30 minutes, so that's it. If folks have questions, maybe throw them into the chat. There is a question, are these live or pre-recorded? No, this is live right now, actually. So if you have questions about MicroPython, throw them into the chat. And like I mentioned, this is a reprise, so I've done this video before, but I'm maybe honing it down a little bit, trying to make it a little shorter and easier to digest. And also, like I said, I wanted to kind of celebrate the twitch.tv/programming channel. So it looks like a new initiative from Twitch where they had the creative channel where a lot of the programmers that do a lot of live streaming would put their content. And it looks like they've kind of spun out the programming content into their own thing, which is really cool because that's actually what got me interested in streaming on Twitch. Is maybe 2 years ago or so. I saw people doing game development on the creative channel. And it was just like, wow, that's really cool that people are programming and streaming it live. You know, who would want to do that? Who's crazy enough to do that? And 2 years later, I've been doing it for about a year now, so it's a lot of fun here. So, oh yeah, and someone mentioned this is a great prototyping tool. Exactly, MicroPython, and you'll hear that a lot actually from the people that created MicroPython. You know, you can very quickly start prototyping something like almost like you were using Arduino. You know, you just slap together some libraries, get some code out there, because, you know, these days, especially with like hardware and things, it's all about what's the minimum viable product. So as fast as you can get something out and get some feedback on it and iterate on it. So this is perfect. But, you know, I wouldn't discount it. I've actually heard of people that have shipped products that are using MicroPython internally. So it's kind of ready for prime time in the sense that, you know, you might be able to take this, and because you can extend it at a low level, you can, you know, really get in there and talk directly to the hardware. You could probably use this in real products and things. So, you know, start with simple prototyping, but then evolve it as you go from there. So, okay, I guess I'm going to wrap this up then. So thanks a lot for watching. I'll put it back on kind of the main headshot right here. So yeah, this is Tony from Adafruit. Again, check out youtube.com/Adafruit. You'll see this video up there and all kinds of other videos. Check out learn.adafruit.com, and that's the Adafruit learning system. Search for MicroPython, and you'll find I've got about 10 guides up there. Start with the MicroPython Basics, What is MicroPython guide, which I'll have a link in the description on the YouTube video. Go to that. That will give you all the info on all the boards, all the other guides that we've got out there. So that's a good jumping off point. And then subscribe or like or comment, you know, let us know that this is good stuff and we'll keep doing it. And check out twitch.tv/Adafruit, where I like to stream things live. I like to do a couple live streams a week. I usually try to do one on Mondays and on Fridays. So this Monday, I guess I'll jump back in and we'll do another stream. Next week will be interesting because we're kind of getting ready for Maker Faire and all kinds of stuff. So I'm pretty sure we'll have 2 streams next week, but we'll see how it goes. So until then, thanks a lot for watching. It's Tony from Adafruit.